Hello, everyone. Thank you for joining today's session on Kotlin Curtains and Spring Web Flags. My name is Andrei, and today we're going to dive into the world of Kotlin Curtains, non-blocking APIs, Spring Flags, and so on. So let's go to the next slide, the agenda. What we will cover today, we'll start with the introduction to reactive programming, to understand why non-blocking applications matter, briefly look at Kotlin coroutines, Spring Web Flags framework. After that, we'll move into live demo, where we build simple news aggregator to pull data from different APIs. And the goal is to give you clear practical understanding of these tools and concepts. So let's jump right in. So why does reactive programming matter? Well, modern apps need to do a lot of things like handling millions of users at once. You can think of streaming services or real-time messaging apps. They also need to stay fast and responsive even during the high traffic events like Black Friday or season sale or live stream and so on. And here is the practical side. There's user resource efficiently. Why spend more on servers when you can do more with less? And finally, apps rely on external APIs. Think of some social media integrations, some connector apps, some payment system, and so on. Reactive programming ensures that delays or errors in these components do not completely stop the system. In short, reactive programming helps tackle these challenges and while keeping your app scalable and smooth. So let's take a quick look at the traditional blocking model like Spring MVC and why it struggles with modern applications requirements we have just seen. First, it uses a thread per request model, which means that every incoming request gets its own thread. Yeah, it sounds simple, right? But there is the problem. Threads are expensive, and when traffic increases, you quickly run out of threads and apps slow down or crashes. Second, it's the blocking APIs. If a thread is waiting for a database call or external API just sitting there doing nothing, what we don't want. And finally, scalability becomes an issue. Adding more users means adding more threads, which means adding more servers. This quickly becomes inefficient and expensive. But it doesn't mean that using Spring MVC is wrong. There's still use cases where we can use it for simple CRUD applications and so on. The diagram here illustrates these problems. This is exactly why we need a better approach. And that's where reactive programming steps in. Okay, reactive programming is all about writing declarative code. You focus on what you want and not how to get it. The main thing is that it's asynchronous and non-blocking. As you see in the previous diagram, it's a problem. Data flows like streams, similar to water moving continuously through pipes. Instead of getting all data in one go, the system processes it piece by piece as it arrives. This makes it ideal for handling large-scale or real-time data. And it's based on the Reactive Manifesto, which defines key principles for creating this reactive software systems. In reactive programming, reactive streams play an important role in handling asynchronous data stream. This reactive stream specification provides a standard for asynchronous processing. Think of it like specification and frameworks like Project Reactor implements these reactive streams. This diagram shows the interaction between the publisher, which is generates the data. Its publisher can be database or API, and the subscriber, which consumes the data, for instance, our app. Yeah, the publisher sends the data to the subscriber through a subscription, and the subscriber receives the data via the onNext call. And when all data is sent, onComplete method is triggered. Also, backpressure is a crucial component in reactive systems. It controls the flow of data between the publisher and subscriber. Some mechanism, you can imagine it like when you came to your grandmother and she already served you a lot of dishes like borscht, vareniki, holubci, and so on, and you cannot consume it all at once. So you have this backpressure mechanism. Also, event-driven systems are designed to react to events as they happen. In our case, subscriber reacts to data availability dynamically, ensuring responsive system. And the push-based model means that the data is pushed from the publisher to the subscriber when it's ready. And this setup ensures that we handle large systems and large streams of data efficiently without blocking threads. And when to use it? Yeah, reactive programming is perfect for high concurrency apps like social media, real-time systems, like stock trading, like event-driven apps, streaming platforms like Netflix, and backend APIs requiring non-blocking behavior. Okay, why Kotlin coroutines? Coroutines are lightweight and non-blocking, allowing us to handle thousands of tasks without consuming too many resources. They simplify asynchronous programming with clean sequential syntax, like the example shown, and they're perfect for reactive apps. They deliver performance without the complexity of traditional threading. Sorry. Okay, here is the classic Java approach to asynchronous programming. Imagine we are cooking pasta and making sauce at the same time. In this example, with completable future to boil pasta and also to make sauce. We're simulating it with the synchronous function thread sleep to prepare the sauce and prepare the pasta, and the results from both components combine it at the end with the then combine function. But however, there is some complexity in this Java approach, managing this future with the callbacks, and you have to be cautious with the exception handling and so on. Let's see how Kotlin makes it easier. So it's right away, it's simpler and more readable. Tasks like boil pasta or make sauce are modeled as suspend functions. We use coroutine scope to launch both tasks asynchronously, and instead of managing threads and future, we use lightweight coroutines with async and await. Async is a coroutine builder that starts asynchronously and returns a deferred object, which represents a result that will be available later. So the code reads like sequential, but it works and runs concurrently. That's the clean, efficient, and far less boilerplate. Okay, what is Spring Web Flags? Yeah, it's the modern non-blocking reactive alternative to Spring MVC. It's built on Project Reactor and integrates well with Kotlin coroutines to handle these high concurrency scenarios that we already considered. And the key idea is to make application scalable, efficient by using this asynchronous non-blocking operation. Webflux uses Naty as its default server. It's non-blocking input-output server, which operates on event loop model rather than the traditional thread per request model that's ensured this better resource utilization and non-blocking. Okay, some key concepts. Web client for non-blocking HTTP calls. You can think of it like the reactive alternative to REST template, optimized for asynchronous reactive data flows. Mono and Flux to main times in Project Reactor. Mono represent a single value or empty result. They are backbone of the Project Reactor and drive data flow in Webflux. Simplify API calls using declarative HTTP client interfaces, making code more intuitive and align it with Kotlin coroutines, and also functional endpoints. You can see here also the example how it looks like. Okay, let's gonna see what we wanted to achieve here. The goal is to retrieve and aggregate latest news and news by category from multiple sources. We will have several endpoints to retrieve these articles. And yeah, using the Spring Webflux and Kotlin coroutines. Let's see the diagram for this non-blocking Spring Webflux. So firstly, the app receive requests from clients. We will use Postman, and Naty server manages the event-driven request handling. So request goes here to the event queue, then it goes to the event loop, and it's not blocked, and then it's routed to the news controller. It will handle requests by fetching data. Then we will create the news aggregator service, which will use Kotlin coroutines async await for structured concurrency. And then we will create two clients, two different approaches, actually functional web client and interface-based web client. We'll see how we can implement them. And also we will use Postman API mock server to return some mock data for this external source APIs. So let's go to the live demo. Okay, firstly, we're gonna create our app via the Spring Initializer to use to actually implement this app. We create the group artifact here, news aggregator, description, package name, and we will add the dependency Spring Reactive web actually to build a reactive application. You can explore the dependencies here. The main is the Spring Boot starter Webflux, checksum module, serialize and deserialize our responses, also Reactor Kotlin extension, and so on. So yeah, I already prepared it, and we can start with the implementing some basic model. So let's create our app. So simple news aggregator app using Kotlin and Gradle. And let's define some model to create responses, to retrieve these responses from external services. So it will be Kotlin data class, and we will name it like news article response, something like that. And then we wanna create some parameters for that class. It will be some title, it will be string, some optional description, some source from where we get this news, and the category of this news. So after that, let's create our clients. The first one will be functional web client, and let's create a package for it and name it news. Build the class news source AP1. Okay, this will be our component class, which will be using functional model. Let's define it as component. Okay. And actually it will have a function to fetch latest news. It will return the list of this news article response. And then
Andrew, sorry, maybe we can do yeah, thank you.
Sorry for that. Yeah. Now it's better.
Yeah, thanks.
Yeah, and for this we need to also implement and inject the news source web client, which we will create in a moment. Source AP1 web client, and it will be web client. So let's gonna create configuration file for that one. We'll name it config, and let's create a news aggregator config, where we will define the web client parameters and URI and so on. Okay, and we will, one moment, we will add configuration annotation and fun new source IP web client. We will create bin which will receive the builder, web client builder, and it will return web client. Actually, we can write it the following way, builder. We will define the base URL for this one. I will check the URL in a moment in the Postman IP server and build. So we're gonna add here the base URL for this API, and it will be the mock server. This we will have new source API mock1 and mock API 2. We will need to get the initial value of this URL. So Postman suggests us to create mock servers. It's out of the box, so we can configure it, and also to send requests with the mock data, what we will use right now. So we copied the base URL and build this function. So let's switch back to this new source API. and we will get this latest news. So let's return new source API web client. We will get this web client. Then we don't need to specify here the full URL, but only for our request. And and we're gonna retrieve this, and we will use the await body function to retrieve it in suspend way. Yeah, exactly. We should add the suspend function. Actually, we can assign here the specified return type, but it's handled it by default, so it's not needed. And okay, we created functional web client call with the get latest news. So let's create the aggregation service. Package service. Okay, so annotative is the service and port. Let's inject our new source API and define suspend fun get latest news, where we will return again this list of article, news article response. And we will return here the latest news. We can also add some logger here, logger. And let's log the info here, start. Starting news aggregation. And let's create the controller, our news controller. It's the same way like we created in this usual Spring Embassy application, REST controller, and we can define a request mapping, which will be news, and let's create we have to integrate this inject aggregation service here as well. And let's implement get mapping is the latest and suspend get latest news. So here we implemented the full flow. So there is the entry point controller, then we will go to the aggregation service, then we will call this get latest news function to retrieve the mocked data by the endpoint. So let's start our application to check it out if it's working. Okay, it started. And let's use Postman to get this event. Okay, we have this 404 not found. Actually, because of the latest, I think we do not find this news. Okay. Yes, we need to have here something like that. Right. We're gonna have this API latest news. Okay. And the API's latest news. And let's restart it again. And we can see here that it successfully returned the first response from the mock API mock. You can see here that we defined some URL. It's what Postman returns us, and also by this latest news URL pass. And here we have the default parameters and the default response, what is returned. What we exactly get by our app, we can also see here this starting news aggregation login. I'm not sure. Yeah. So let's define another way of the client using HTTP client interface. So generally, we will create an interface. Let's name it news source API 2. And we will mark it as HTTP exchange functions, also with the news URL path, and we simply define our functions like that. Get latest news, and the second one will be get news by category, which will return also a news article response. And we simply need to define get exchange annotation, which is kind of similar with the specified URL path and here as well. But here we also need to define the path variable, right, for this category. So basically that's it for this client. Under the hood, it will generate the proxy implementation of this web client, but we also need to create configuration for that type. So let's go to the news aggregation config again. It will be another bin, fun, news source, I guess. API to web client builder, and it will also return, but we have to check the URL here for the Postman. It will be the second one. I go to the variables and get this value here. So let's set it. Another thing what we have to do is to create bin for our web client, which we will inject directly in the news aggregation service. It's centralized ways of creating such a web client configuration. So let's define another bin. It will be, let's name it news source API 2. And we will inject here news source API, web client, and we will create exactly web client adapter factory, and this client of the type for our news source API interface, which we will inject in few moments. And let's return news source API. So yeah, exactly. Create here the bin to return the client, and let's inject this here in the news source API 2, and let's do it in the following way. We will call file, we'll introduce news1 for this call, and we'll introduce news2 for the following one. So this one uses this endpoint, this one uses this endpoint. However, we need to integrate coroutine and use coroutine scope and async await function here to not have blocking scenarios. For instance, when this endpoint will have some delay of 4 seconds and this endpoint will have some delay also 4 seconds. So in general, it will take 8 seconds, but when we will use Kotlin coroutine, some async await function, it will decrease by 2. So yeah, let's implement it in that way. Here we need to define coroutine scope and make async invocation for this one. Also async function for this one. Okay. And then just return the result like that. We can log the information as well and return result. So here we have the synchronous way with using Kotlins to retrieve these functions from different source APIs. We can have a lot of different calls, but for the presentation purposes, we use only 2. So let's check if it's working, and we can call this function. Let's start again our app. Okay. Okay, we have some problem. New source API to web client. Some conflicts in the aggregator config. Okay. Web2 client. Create a single bean. What is actually builder base URL? Gator service. Let's check it out. What is wrong here? New source API. Okay. New source API. This one, it should work. And the new source API here, the same one. And we inject this one here and return a client. Okay, let's try it again. Okay, there's multiple bins, but I don't see where.
I guess you need to like add like some bin name for both of them and like qualifiers to solve this issue.
Yeah, but it should work without it in general. Okay.
You can just
Let's-
define some like attribute in bin name like as a value, and that's it.
Okay, let's try it. And the qualifier. With the value. But why it doesn't work in that way? It should like use the name of the default bin and name of the method here. There is something with the names. New source API. Okay. Okay, let's do it in that way. New source API. New source API web client. Okay, we have one bin and then we define another. Do you see the problem? Maybe I'm just a stupid one.
Try to do the same in your new source API one with qualifier.
Yeah, that's strange actually, because yeah, it works previously. I just run it. It's as always. Okay, let's API web client and builder. Okay, let's find it. Okay, here.
Maybe
Yeah,
you should
the
add
same.
qualifier to new source API one, because you create bin with some specific name now, but you didn't add that qualifier here.
Yeah. But I'm not sure if it's a problem actually. It's like a joke. New source API web client. Okay. Okay, it's not working. Thank you. But yeah, something with the idea, because in general, when you define with the different names, it names the bin with the name of the functions, and we don't need to directly and explicitly define these qualifiers. But yeah, for now it's working. So that's the strange one. But okay, nevertheless, let's see if it's working now. So let's call so in general, firstly, we want to achieve this response from source API mock1 and the latest this one from the source from the second one. Let's call this And we can see that we successfully call our, retrieve our news from both APIs. And let's also see how it works with the error handling. And let's create another endpoint for this. It will be this category, suspend get news by category. Let's create function in the aggregator service. In the same way with the coroutine scope, with the async builders, and so on. But we need to define in our source API here function get news by category. So we will retrieve in the same way, get news by category. Let's check how if it works by the API mock. So we get with the science category, for instance, we should get the response. So let's start the application, restart actually. Okay, let's call the API again. And let's call, for instance, we wanted to get news by science category, and let's try it. But we'll receive this 500 error because missing pass variable value category. Okay. Let's define.
I know what is the problem. I think you have typo in news source API web. You missed the S. You have news source API instead of news. So it's the issue.
Okay. Okay, thank you for that. But yeah, yes, this sometimes happens. Okay, thank you for that. Okay, let's define here the pass variable for a category. Restart it, and maybe add some. Okay, we have here some login. Again, we want to get the science, but we get again the 500. What is done? Assert not null. Let's go to the news category science. HTTP method is required. Okay, get news by category, news controller. Okay, news, and then we should get here category. Okay. And here we have the URI. And URI is also a category and science. Okay, let's do it again. Get mapping category, pass variable, and we get the news. Okay.
I think you use front connotation. I think you use HTTP exchange. We should use get exchange, I think.
Yes, you're right. There's again a typo. Get exchange here. Thank you. Yeah, exactly. Let's restart. Okay, now we have the right error message. So we get the 404 not found for the category signs. It's actually our second one. So let's fix that with the category science, and we want to get this info. So let's switch that. Okay. Category science. Okay. No, it should work, but it doesn't. Okay. Category, but it should work. So, and we can show here, we can add here on status method where we can handle the exception in that way that when we have the response, actually what does this on status means? When the retrieve function get an error, we intercept this with the onStatus method, and then we use response status, check if it's 400 or if it's 500, and then we can handle it how we want. For instance, with the throw runtime exception or throw mono error. And we can see here in the example when we restarted and try again to and here we can it's not starting news category by 500 or first we get news category signs. Okay, again the problem is the news category signs should be the right one. Okay, and it's not found, but it gets for the first one. Gets news category here, and actually we can add here the private logger. Failed to fetch, and we can, for instance, return not the runtime our response status exception with the status code and some message. Okay. What the problem now again? Handler not found. Category, news category. Again, it's for the first one. Okay, again, the typo is this news. Why it's called news? Okay, let's check it again. It's actually news. Okay, we get news by category here. Then we define the category URI, which is category science exactly, but why it's where it gets the news.
Maybe you have base like pass on the top of the
Yeah,
class
already.
for the second one.
Yeah, but the pass is here, so it's without. Okay, let's check it.
But problem is the second, I think, with the second one, with the second client.
Mhm.
Can you please open new source API too? I think we haven't used like base
Yeah, okay,
pass
yeah, I
too.
see here. But why it's not working for the first one? For instance, we are starting a new segregation for category science, why it's called by the second one. Okay, let's then implement this for such use case. Let's create some error handler here, exactly for this HTTP interface client. Let's create some function like error handler and define it like that. We will return some filter, exchange filter function here, and then we will define the return exchange of professor, exactly this one, and we will restore some response status exception with the status code and failed to fetch. And for this, we will just mono and just response. Okay, and we can add this error handler exactly here to this filter functions error handler. This will actually handle this kind of exception that we can see it here. Let's define also the logger. Okay, and let's log the error, the actual error here. Okay, and let's exchange function return. Okay, would be good. Okay, let's continue. Stop and run. And let's see the actual problem. Let's call it again. Okay, and now we see that the error is changed and we handle it successfully. So yeah, it was exactly the problem with the second API, and this function helped us filter the error here and return some custom exception that we want to handle here. Let's actually fix this problem. Is for it just was for demonstration to see how we handle these errors. And let's change the default to science here in the mocks service. So it should work here. And then let's call the category again. So yeah, finally it successfully returns data by category. It's from first API source, and this is from second one. Yeah, in general, that's it from my side. What I want to show. Sorry for these errors during presentations. That's always happens. Some typo and some things of it. But thank you a lot for your attention. And yeah, that's mainly from my side. And here is some material links for this presentation. And yeah, that's it.